Paper, please. Right here. Says right here, similarity is congruent angles. I expect you to have this memorized. Ratios which are equal. Help him out, Coop. Help him out. All right. Now, to check for similarity, I want you to match up the corresponding sides and reduce. Go. Corresponding sides and reduce. Match up the corresponding sides and reduce as fast as you can. As fast as you can. Fabulous. Miss Sullivan, what's the reds? And?
Oh, sorry, 8.
9 to 8. All right. And Jay, the greens? Five goes into 45. Okay. 9 and 8. Here, the ratios are equal. Ratios equal. Therefore, they are similar. Ready? Take a look here. Trace red to red. And watch carefully, guys. Blue to blue. Careful that blue is not 32. Go. Reduce. And I need you to put that back together. There's a reason why that was due. Right, Federico, give me the reds, left to right. 5 to 3. Excellent. And Emily, give me the blues. 5 to 4. And this would be a not similar because the ratios don't match. Now, when things are similar, a wonderful and amazing pattern happens. I want you to get the cubes out. You have a 1 unit cube, so a really small one. And then you have a 2 edge unit cube. Get those out on your desk. Step number 1, just trace the edge with your fingers. Just trace the edges, edge to edge. Trace it. Repeat after me. Say edge to edge. That's just length. Length, show me with your fingers, 1, 2, or 3 dimensions. Length, just length. Show me only one. So your scale factor here is 1 unit to 2 units. Now, get the cubes out. I like you to count the squares that are visible. That's going to be the surface area, the visible squares, and then the visible squares. All right, for the larger. So that's called surface area, the visible squares of the small and the large. I'll give you about 45 seconds. Do that yourself. Use the cubes. Okay, you see the squares, sweetheart. Hang on. Let me. Okay, for example, look at the big one. Ready? Yeah, just the squares you physically see. There's one side, right? Okay, and then you go around. Okay. Lucas, get your hands on the physical thing in front of you. So there's 4, and now count the sides. How many? 24. Okay, so going this way, Nico, how many physical squares are visible in the small one? Try it again. Count. That's why you have physical things to touch. 6. Great. Lucas, how many squares do you see on the larger? Visible. You just counted. 24. It is. Now, I want you to count how many plastic cubes are there. Plastic cubes. That's going to be your volume. Plastic cubes. Physical plastic cubes. Talon, for the very small one, how many physical plastic cubes is it? Just one. Fabulous. All right. And Jordy, how many physical plastic cubes are in the larger one? Just grab it from somebody else. How many physical plastic cubes are there? 8 is correct. There is a lovely pattern here. Watch. 1D, 1 to 2. 2D, 6 to 24. 3D, 1 to 8. Let's reduce it. You can't reduce this anymore. It's just 1 to 2. Can't reduce this anymore. It's 1 to 8. You can reduce this. Federico, 6 to 24 is 1 to 4. Watch what happened. Put this right above. This is 1 to the first, 2 to the first, 1 to the second, 2 to the second, 1 to the third, 2 to the third. Put that right above. Here's what's going on. Last night's videos, you know that when you change dimensions, you're going to change your ratios. When you change dimensions, you're going to change your ratios. Keep that where you can see it. Go to the first page of today's lesson. You like to see that? Yep. First page of today's lesson. You can pack it. You don't need to get up right now. Why is that gone? All righty, guys. Step 1. Put your finger right here. Example 1. Out loud. Read. Go. Read. Finger. Out loud. Go. Read. Finger. Out loud. Go. Finger. Paper. Out loud. Go. Start underlining the key words. And I'm going to go over this with you. It should take us about an hour. All right. Step 1. We are told they're similar. So immediately put the little squiggle there because you can't use any of these shortcuts unless they're similar. All right. Surface area above the word area. How many dimensions? Show me with your fingers. 2. So put 2D right there. That ratio, put x squared, y squared. Volume, underline it. That's 3D. Larger is here. Smaller is your unknown. Ready? Let's do variables. That's x to the first, y to the first. You are given the 2D ratio, 6 to 9. What I'd like you to do is backtrack. What would the first degree ratio have to be? Then take that information and kick it forward to the third degree. Backtrack. Okay, Abby, what would the first degree ratio be? So square root of 16 would give us 4, and square root of 9 is 3. So that's just your x. And now go forward to the cubes. The D, yeah, 4. Got 64. All righty. Varshini, 3 times 3 times 3. 3 times 3 times 3. There we go. Now, watch. Volume of the larger is this. Volume of the smaller, I don't know. So you're going to do a proportion. I highly recommend you label your proportions, either left to right, large to small, 1 to 2, whatever it is. So I'm going to go 256 meters cubed, unknown meters cubed. I'm going to use the 3D ratio of 64 to 27. The reason is because volume is 3D. Cross multiply. You don't get to touch calculator yet. 64 times x 256 times 27. Once your variable is completely by itself, you can, and try to that without touching your calculator, but if you're going to be a lazy bones, as long as you show that, redo. All right, Lucas, what'd you get? 108 what, sir? Yep, 108 meters cubed. Thumbs up if you are in agreement with Lucas. All right, let's come down here. Ready, and read out loud. Go. Underline the keywords. Similar. You underline it, put the little squiggle there. Surface area, underneath the word area, write 2D. Find the volume, put 3D of the second solid. That's going to be your unknown. Remember, you start out with what you need. So look at what we have here. Surface area. Talon, area is in what dimensional position? 1, 2, or 3. Area. Go like this with your hand, like you're painting the wall. What area is how many dimensions? 2. All right, I need you guys reduce 7, 72, and 8. Reduce it. Miss Johnson, what is that? Okay, so we have in the second dimension, we have 9 and 1. I need you to backtrack to the first dimension and then take it and bounce it over to the third. Go. So Talon, square root of 9 is? Yep. This is 3 and 1. All right, now go forward. Federico, 3 times 3 times 3. 27. Federico again, 1 times 1 times 1. 1, bam. Now we look at what we want. We want volume. Volume's 3D. So I'm going to go solid 1 to solid 2, noticing I'm labeling. I'm going to go 162 meters cubed. Unknown, meters cubed. I'm going to use volume 27 to 1. Cross multiply. 27 x 162. Following along. 27, 27. There you go. X is by itself. Yes, you may grab a calculator again, or you could just hack away at it. Where's that key? Got it. Nico, what'd you get? X is 6 what, sir? Cube. There we go. Nice job. Ready. This page right here. Ready and out loud. Read. Go. I noticed that. I'm always a person. Yes. All right, so these solids are what keeps moving? Okay. Similar. Ready? They're similar. Ratio, surface area above the word area, 2D. Put it right here, 25, 16, x squared, y squared. Backtrack, find x to the first, go forward, cube it. Get me both of those right off the bat. All right, Miss Sullivan, what's our X1 and Y1? 5 and 4. Coop, what's our cubes? 64. All right, let's look at what we want. We want the volume of both. We were told that the larger cylinder right here is 5 units. We write our volume equation. Volume equals base times height. Volume equals base times height. Better believe this is going to be a test question. We shade our base. And that's pi r squared. We trace our height. Okay, we're doing volume and our height. So the problem is we are missing pieces of both. So right here, we are missing our radius here. Trace that. Just trace the radius with your fingers. Radius is how many dimensions? 1, 2, or 3? Okay, it's just length, folks. Length. Okay, so it's 1 dimension. You're going to go 5 over unknown radius equals 5 over 4. I'm using this one. You shouldn't even need to cross multiply for this. Take a very close look there. Miss Johnson, what does R equal? 4. You got it. This is going to be 4. All right. For the heights, again, only 1 dimension. So it is still 5 to 4. An unknown height over 24. Cross multiply, solve. Height is 30. You have everything you need. Your radius, 5 squared. There's pi, 30. Your radius here is 4 squared. Pi, your height is 24. Get me both answers in pi form. Do not say it out loud. Raise your hand when you're done, and I'll tell you if you're correct. I'm doing it right now. If I don't, go back, read the problem. I think they're units. Or let me check. Hang tight. You are correct. Generic units. Keep it in pi form. You're good to go. Wait to your answers. Don't say that loud. Yes, ma'am. Good to go. Wait to your answers. Don't say that loud. Yes, sir. Good to go. Points when you're done. Do your own math. Turn page. Howdy, sir. Points. Yes, sir. Points. Yep. Good to go.
Oh, wait.
And good to go. Sam, you need to clean it up there. You actually need to do the math. Just ignore the pie. Just ignore the pie and do it. You actually need to do it. No, you didn't. No, you didn't. You actually, on the hand side, you're gonna go 5 squared times 30. On the right hand side, you're gonna do 4 squared times 24. You actually have to do this. So that is right. Yeah. Yeah, you are correct. Cross multiply, solve your searches. I think you said that one. That 135. Which one is that? The Airy. I hate
the larger one always go on the.
No, it doesn't. I really don't care what it goes. What does matter what it goes. If you go left to right, there's left to right.
I'm confused on like how you like set up.
Well, I tell you, it's the scale factor of, so put an A there.
Oh, yeah.
That's A, that's B. A. That's why you, they're not, you don't miss stuff up. Okay. Howdy. Yep, good deal. Yes, show me. You're good. Students, I'm gonna do another problem up here. If you're like not feeling too good, come up and do one more problem with me, okay? I'm gonna do page 7, so come on up. Page 7. Scale factors, first dimension, yes. Jordy? You do, okay, right?